All right, so let me share my screen real quick. So say yes in the chat if you can see my screen. If you can't, say no. So can everybody see my screen? Pretty good? Yes? Okay, very good. Today will be our third lesson of solving inequalities, all right? And today will be about compound inequalities. And also for just a note for last week's homework, last lesson's homework, it was on the graphing inequalities and doing the interval notation. So a lot of you guys solved the inequalities, but you did not put it in the interval notation or graph it. So make sure. For those who did not do it, I didn't give a grade, so you have to redo that. Make sure. And the point of the lesson was to do the interval notation, graph the inequality. So make sure you graph the inequality and write it in interval notation. All right. Today we'll review those topics. Okay. So first we're going to go over our homework questions, and then second we're going to go over compound inequalities. Then how to graph those compound inequalities, and finally some practice problems. All right, so let's start with these homework questions. So our first question, I'll give everybody a few seconds or a few moments to put your answer in the chat, and remember to denote it in the interval notation. And also, I know you can't do like the graph. I'll just, you don't have to write the graph, just put it in interval notation, and then I'll write the graph later when I'm walking you through the problem. All right. All right, let's see. So we have x is greater than -8. Okay, we also have x is greater than -8, and then -8 to infinity. Very good. All right, so does anybody have different answers than that? Does anybody have different answers than x is greater than -8? Right, any different answers? If there are no different answers, then that's good, because x greater than -8 is the correct answer. So let's see how we solve this. This is just simple distributive property, right? So we move the -4 to the other side. It's going to be -48 is less than 6x, then x is greater than -8. So if we put this in interval notation, what has to be our first term? Our first term, since x is greater than -8, the -8 has to be our first term. The lesser term is -8. And then x can be anything greater than -8, so it's going to be the interval -8 to infinity. All right, so if you graph this right here, then let's say this is 0 and this is -8. So I saw some of you guys, when you graph this, you list all of the numbers on the number line, like 0 all the way to -8, and then -10, and then 0 all the way to like 25. All right, you don't have to do that. Just 1 point, -8, and then do the graph. You don't have to do all of the points. So since negative h right here, you see the sign is not included, we're going to use this open circle like this. All right. Are there any questions? Okay. How do you do an infinity sign? Oh, you can do the alt/option plus 5. Ah, actually, let me try that. Hold on. Does that actually work? Alt, alt, and 5.
It works on an iPad, but I don't think it works on a computer.
It does. I'm on a computer and I tried it and it works. It's just option or alt and then 5.
Where's the option for the alt? Oh. The alt F5 or just 5? I don't know.
Just 5.
What? Just 5? Okay, well, it doesn't work for me. Is that like on like a Mac or something? I don't know. Anyways, let's go back. Second question. So everybody just post your answers real quick. Then I'll walk you through it. All right. Let's see our answers. X is greater than or equal to 24. Very good. So most people got greater than or equal to 24. Okay. Good. So now let's see. So to get rid of this 2 in the denominator, you have to multiply everything by 2. So 7x minus 4x is greater than or equal to 72. All right, then 3x is greater than or equal to 72. Divide both sides by 3. Get x is greater than or equal to 24. So if you write this in interval notation, again, x is greater than 24. So 24 is the lesser number, has to be the first term. But if you pay attention to the sign right here, then it's actually included. Right? It's greater than or equal to. So this is included, and it's to infinity. And then if you graph this on a number line, we have 24 right here. And since it's included, we have a closed circle to the right. Very good. All right. Our third homework question. So I'll give you a few moments for everybody to put their answers in the chat. All right, we have 29 to infinity. Okay, so x is greater than 29. All right, so most people got x is greater than 29. Very good. All right, so look at this. You have to multiply everything by 7, right? So it's going to be 3x plus 4 is greater than 91, right? Then subtract 4, 3x is greater than 87. Then divide both sides by 3, x is greater than 29. We write this in interval notation, going to be 29 to infinity. Right? If we graph this, we have our 29 right here. And since x is not included, 29 is not included, it's going to be like this. So, are there any questions? Any questions? If there are no questions, then I will review. Right? So graphing inequalities, we all know how to graph. So it's from one point to another. All right. So our key point here is that if it's less than or equal to or greater than or equal to, we use the closed circle. So our closed circle. And then if it's less than or greater than, strictly less than or greater than, we use our open circle. So that's just a little reminder on how we do it. So let's do a quick example. Our quick example, x is less than 9. All right, so let's look at this sign. All right, the sign x is strictly less than 9, which means 9 is not included. So that's an open circle, and it's less than, so it goes off to the left. All right, so that's how we graph. It's pretty easy, right? So are there any questions so far? Any questions? So let's see who's here. William, do you have any questions?
No.
All right, very good. Let's see. Isabella, do you have any questions? Is it everything good so far? All right, you can type in the chat if you have any questions. So hopefully everybody is good with this topic. It's pretty easy. And then let's review our interval notation. So the definition of an interval is a set of real numbers that contains all real numbers lying between any two numbers or points of the set. So an interval, for example, is 3 to 4, and that set contains everything in between 3 to 4. And our key point again here is key point. Right, just a reminder here, if it is included. If the point is included, then that means it is a set of square brackets, or just one. And if it's not included, if it's not included, it's just a parenthesis. So if you have, like, for example, all the real numbers in between 3 and 4 with 3 included and 4 not included, it look like this. So you can have one square bracket and one parenthesis. So it's possible. To have one square bracket and one regular parentheses, right? It is possible. All right, or you could have both regular parentheses or both square brackets. All right, let's go back. So now let's actually, any questions on this? Any questions? All right. If you do have any questions, just make sure you don't even need to type in the chat. If you want to type in the chat, you can, but you can just unmute yourself and interrupt me anytime you like. Right. So today we're going to be talking about compound inequalities. All right. So compound inequalities basically a compound inequality is a conjunction of two individual inequalities joined by and or. All right, so this sounds a little bit awkward. All right, so let me give some examples. Some examples. Right, we have, let's say, x is greater than 7 and x is less than 11. Right, so x is greater than 7 and x is less than 11. So it's two inequalities, two individual inequalities joined by and. Right, so you also have an example of, so this is one of and this is one of or. So let's say y is less than -4 or y is greater than 11. All right, so or 12 if you don't want to use 11, let's use 12. All right, so y is less than -4 or y is greater than 12. All right, so there's a big difference between and or. All right, so if you notice here, what do you notice about the and? Make some observations about the and inequality. So this one, the and inequality. So make some observations about this one. Right. So what is this? What can you actually do with this? All right. So who can make an observation about this? So we have William. Okay. So William, what do you have about this? What can you observe about the and inequality? Right.
So if x is greater than 7 but and less than 11, then that just means we could do the interval notation so that x equal so that it could be normal parentheses, then 7, comma 11.
Yes, very good. So what is this actually? So let me rephrase this. So if you have an and inequality, you can actually combine it. You can combine, and that is very useful. So usually with the or inequalities, you have to solve individually, all right? But with the and inequalities, you can combine them. So look at this. So we have x is greater, well, less than 11, right? And it's also greater than 7. So if we combine these, we can see that we can actually combine these, right? And we can see that x is going to be in between, right? It's going to be in between. It's going to be in between 7 and 11, this interval, right? So we can actually combine this with our and inequalities, right? However, with our or inequalities, we cannot, right? Let's look at this. Y is greater than 12. Y is greater than 12, but it's less than -4. Does this make sense? This does not make sense because it cannot be less than -4 and greater, right, than 12 at the same time because -4 is less than 12. So it does not make sense if you combine these, right? So you cannot combine the so for our or inequalities cannot combine, all right? Cannot combine these. But with our and inequalities, you can, right? So very good observation, William. Good job. So next we have how do we solve these compound inequalities? So let's give an example of a compound inequality. Let's say 2x, right? So we have 2x plus 1. 2x plus 1 is less than 3, right? And 2x plus 1 is greater than -4. All right, so how do we do this? All right, so I'll give you a couple moments to try and think about this. Just, you don't need to do it. Just think about, brainstorm ideas on how we do this for a second. All right, so does anybody have any ideas on how we do this? All right, so does anybody have any ideas on how we're going to solve this and inequality? And so we have uh, one chat message from William. All right, so 2x plus 1 is equal to, it's in between -4 and 3. Right, it is in between -4 and 3. So William, you have ideas already? Okay, so if you could unmute yourself and let's see what you have. Right, so how are we going to solve this?
So we're just gonna solve this by we can't do 2x plus 1, but we know that 2x plus 1 is less than 3, but is greater than -4. So it has to be somewhere between -4 and 3, and does not include -4 and 3.
Yes, right? So then we can combine these, right? So remember, you can combine. Remember, you can combine these. Right, so remember, you can combine these. However, for our order inequalities, remember you can't combine, so you have to do it separately. So let's look at this. Well, now that we combine them, how are we going to do this? Because we can't, how are we going to do this now? We have 2x plus 1 in the middle, and that's in between -4 and 3. Well, actually, we can actually do these simultaneously. We can do this simultaneously. So let's look at this, right? Let's add, let's get rid of this 1 first. So if you get rid of this 1 first, what you need to do, you have to subtract 1 on both sides, actually. Subtract 1 on both sides. All right? Subtract 1 on both sides. So let's look at this. After you subtract 1 on both sides, until you subtract 1 here, okay? So then you get rid of the 1, right? You get this, right? So afterwards, then what you get? You have to divide both sides by 2, right? So remember, you can do this simultaneously. So then you have x is greater than -5/2, and then it's less than 1, okay? So then if you put this in interval notation, then it's actually -5/2 to 1, right? That's how you do it. Okay. So what about the OR inequalities? So let's say we have, let's do a similar example, except we have our signs a little bit switched now, but remember, we cannot combine, right? All right, so let's look at this. If we cannot combine, then let's let me make an so let's see, 2x, let's do this. So it's less than -4, and 2x plus 1 is greater than 3, right? So now if you combine this, it won't make sense, right? So that's why it's an OR inequality, right? So does anybody have any ideas on this? How are we going to do this? Any ideas? Right, so I'll give you some time to brainstorm some ideas. All right, so you don't have to actually do the problem. So let's just brainstorm some ideas. Think about it for a moment. How are you going to do this? All right, so then we'll reconvene and let's do this problem. All right, so I'll give you a few moments to think about this. All right, so we have some ideas from Isabella. All right, so 2x plus 1 is already less than -4, right? So it can't be greater than 3. That is true, right? That is true. Okay, so that's why you can't combine it, right? Very good. Then we also have some ideas from William, right? So William, how are we going to do this, right? Also, let's see, Hugo commented. The answer is ditto. What is this ditto? Is this some new thing that I don't think? Hold on. Well, what is this ditto? What is a ditto? Hold on. Ditto. No, ditto meaning. It's a Pokemon? The same thing again. Oh, it's the same thing again. Basically means you said it. Okay, read dictionary. Okay, now I know ditto is the exact same thing. Well, Hugo, you're actually wrong. It's not the exact same thing, but it's very similar. Right, so let's search up this Pokemon. What is a ditto Pokemon? Oh, you don't know? Okay. No, it's this. What is this? Oh, it's one of those things that can transform into anything, right? That's the ditto. It's a Pokemon. Look at this. Okay. I searched up what a ditto is. It's a Pokemon, and it means don't know or the same thing. Okay, good. All right, so how are we going to do this? All right, I think William raised his hand earlier. So, William, do you have any ideas?
I guess we could just subtract 1 from all the numbers. So it's 2x is less than -5, or 2x is greater than 2, and then we divide every number by 2.
Yeah, so right now we have to solve it like individually, right? You have to solve everything individually. So then we're just left with this, right? It's less than -5/2, but it's also greater than 1. How are we going to denote this in interval notation? Right? So because we have two outcomes, right? So we have two outcomes, and we're going to denote them simultaneously, right? So we have two outcomes, and they're both represented equally, right? So let's denote this. The x is less than -5/2 first. So we're going to have -5/2 is going to be the bigger number. So since x is less than that, it's -infinity to -5/2. And then this one, x is greater than 1, all right? That's 1 to infinity. All right, so how are we going to do this? How are we going to combine these? Well, actually, we're going to use something called a union, all right? It's going to be like a U. It's a union. So we're going to union these two these two intervals, right? Because they're not individual anymore. They're conjoined by or. So we're going to actually have to join these two intervals. So it's -infinity to -5/2 union 1 to infinity, right? And this union sign, we're not going to use that much in this Algebra 1 course, but we're going to use it when we're denoting these or inequalities. And you'll see this union sign later when you get into more advanced mathematics. So it's good to know. And also, so what is actually a union? So just a side note right here. Just a side note. All right. So let me explain what a union is. So if you have two identities, right, then this whole thing is going to be A and B. Then this whole thing, right, this whole thing is going to be A union B, right? And then this intersection here, right, this intersection here this is going to be A intersection B, so it's upside down U. But that's just a little note there to the side. But you'll use these symbols more in advanced mathematics. And so that's how you do the interval notation of these OR inequalities. You have to use the union sign, right? And you have to solve these two inequalities separately. All right, so are there any questions? All right, so does anybody have any questions? Let's see. Does anybody have any questions? Kaylee, do you have any questions?
No.
Okay, very good. Let's see who's here. Aiden, do you have any questions? So far, so good, right? No questions?
No.
Okay, very good. And so I think everybody is good on the subject, right? So this union and then the OR inequality. So this one is a little bit tricky. So if you do have any questions, then make sure you say so. Okay, so now let's go on to how we graph these compound inequalities. So let's see, all right? So for our AND inequality, for our AND inequalities, for our AND inequalities, they're going to be between two numbers. They're going to be actually between two numbers. So they're going to look like this. So let's say this is A, so it's going to be A to B. And the parentheses can be square brackets too. So this is A and B, and then this is how we're going to graph this, right? So A to B is going to be like that. That's how we graph it. The AND inequality is always going to be between two numbers. That's why we can actually combine those two separate inequalities, right? Then we have our OR inequalities. We have the OR inequalities which are different. We're going to have them branching out in different directions. Right, so it's going to be negative infinity to A union B to infinity. It's going to be like that. So what does that look like? It's going to be like A, then we're going to have like that. And then B is going to branch out in different directions. So that's how it's going to be looking like. So let's do a little quick example on how we graph these. So let's say we have x is greater than or equal to, let's say it's 5. Greater than or equal to 5, and x is less than -6. So let's see. How are we going to graph this? All right, so can anybody help me? Can anybody, so if you can unmute yourself and explain what the union means again. So the union, basically, you have to pay attention to this U sign, all right? So this it's just a U, okay? The union is and basically combines these two intervals, right? Combines these two intervals, right? Because I mean, a compound inequality is a conjunction. It's a conjunction of two individual inequalities, right? It's a conjunction. So it has to actually be together, right? So these two intervals are related, right? So that's why we use the union, because they're unioning two intervals together, I guess. Right, so let's go back to this example. Does anybody have any ideas on how we're going to graph this? All right, so let's see. Michelle, do you have any ideas on how we're going to graph this example? Could you help us with this? If you have any ideas and you don't want to talk, you can put it in the chat. Let's see who's here. Hugo. Do you know how to do this problem?
Wait, can you see it again? Um, let's see. So first you have to like denote the interval notation, I think.
You could. Yeah, so it's less than -6, so it's negative infinity to 6 union the square bracket 5 infinity. Okay.
And then you graph it.
And then you graph it. How are you gonna graph it?
You draw a number line, 0 in the middle, negative 10 and 10 on either side.
Yeah, okay.
And then you draw -6, and then you draw
What kind of dot? Is it closed or open?
closed.
Are you sure?
Uh,
Included.
sorry. It's open, and then the other one is closed.
And where is the other dot?
The other one is on a 5.
Yeah. Right, and let's go back to our -6. Which way is the -6 arrow going to be pointing?
It's going to be pointed to the left, and the 5 one is going to be pointing to the right.
Very good. And so that's how you graph. All right, great job, Hugo. Very good. Okay, so that's how you go in graph. So you can see they are branching out in different sides. That's why you can't combine them, right? Because it's not between two numbers A and B, right? All right. Very good, very good. So now we actually already talked about this compound inequalities, the interval notation. But remember how about we do it again? So for the and inequalities. And so right, what we're gonna have is we're going to have it's gonna be between two numbers. It's gonna be A or B. Okay. Or you can have like what? One square bracket and then the other, like a regular parentheses. But you get me. And then the or parentheses, the or inequalities, right? Or inequalities, right? They're not between two numbers, right? It's branching out to different sides. So what you're gonna have is gonna have negative infinity to A union B to infinity. Right. So that's the interval notation for that. All right. So good job, everyone. Let's move on to our practice problems. All right, so I'll give you everybody a few moments, all right, to do this problem. Okay, so but also don't graph yet. All right, so don't graph yet. You just solve the inequality and denote an interval notation. Later we'll graph. All right, later we'll graph. Okay, so this one don't graph yet. Yeah, and then just put it in interval notation. All right, let's see our answers. Do I have any answers? No? Okay, I think this one was pretty hard. Okay, let's do this. All right. So this one, you actually can't combine it from the start, right? So there are some problems where you cannot combine from the start, right? So we're actually gonna have to do this separately because you see these two values that these two values are not um are not like the same, right? So we can't combine them yet. All right, so let's look at this. So let's see, it is uh okay, so let's look at it. So let's solve them separately. All right, so let's solve each of them separately. So multiply everything by 3. Let's work on the first equation, right? So multiply everything by 3, right? It's 3x plus 2x is less than or equal to -5, and then x is less than or equal to -1. All right. Second one, we have 6 times 9 plus 3x is going to be 54 plus 18. X is less than 18, then 18x is less than negative, what is this? Negative 36. All right, negative 36. Okay, then x is less than -2. Oh, okay. So this one is actually kind of tricky, right? And this doesn't even be like between two numbers. So this one is actually a bit tricky. So this one I
Excuse
got this. Yeah.
me, did you forget to multiply by the other side by 3?
Oh, right. Sorry. That changes everything, doesn't it? Okay. Thank you about that. Thank you. All right. So thank you. That was my mistake. Sorry. That was kind of careless. Okay. All right. So let's look at this. This one is actually not between -3 and -2, right? It's not between it. All right. So how are we going to do this? There are some occasions, right? And partly this is my mistake because I was in a rush day, so I just got this problem off an online website, and that website turned out to be kind of trash. So hence this problem. But I didn't mean this. But why not? This is another occasion, right? That's another occasion. So this could happen, right? This could happen. So let's look at this. Let's look at this. So when you have x is less than or equal to -3, so let's actually when it's less than or equal to -3 and x is less than -2, we can actually cancel out one inequality because x is less than both, right? So we just say like the more restricting one. So let's look at the more restricting one, right? So let's look at the more restricting inequality. So it's the 0 and -3 and -2. So x has to be less than -2, and then x is also less than or equal to -3. So which one is the more restricting inequality? So does anybody know which one is the more restricting inequality? All right, William, do you have any answer?
I think it's supposed to be x. X is less than -2. I think -2 is the more restricting one.
Are you sure about that?
Or is it -3?
Which line is the shorter one?
And the -3.
All right, let's think about it this way. Are there more numbers less than -3 or more numbers less than -2?
There are more numbers. Oh yeah. Oh, there are more numbers less than -2.
Yes, that means there are less numbers less than -3, which means -3 is the more restricting one. Then -2, we can actually cancel out. We can actually cancel out. Right? Because it has to be less than -2, but it's also includes, but x also has to be less than or equal to -3, so it's more restricting. So we should go by that. So we can actually get rid of this. Right? You can actually get rid of this because if it's less than or equal to -3, then it's also less than -2, right? So it doesn't make a difference. So we can actually cancel it out. So that's one way how we can do that. All right. So now let's go on to our next problem. All right. So the other one was a pretty bad problem because that website I got it from, didn't really fulfill my expectations because it's supposed to be between two numbers. That's what we were practicing. But this one is also good practice, right? Because it practices your logic, right? So that's also good practice. So, and also I kind of based the homework questions. I kind of got the homework questions from that website too. So you might encounter more of those problems. Sorry. All right. Anyways, let's do number 2. Hopefully this one will be good because I didn't check these before. But it looks fine. So. Oh, famous last words. Does this actually work? I don't know. What is it? Oh shoot, this looks bad. Hmm. Okay. Okay. Actually, I'm gonna change the problem a bit. All right. Let me change the problem a bit. How about we make this we're going to make us actually hold on a second. Let me solve this real quick. Then we can do more about this. Sorry about this. This really bad problem. Okay. 105 is oh, this is bad. This is bad. Okay. -3. Okay. All right. Hold on a second. Let's actually make this greater then. All right. Let's change that a bit. There we go. All right, now do it. Man, this website is pretty bad. And so I'm gonna revise the homework before I send it out. Because I got those from that too. All right. Okay, so let's look at if you have any answers. All right, x is less than -2. And then we have, oh, that was the last problem. Yeah, okay, sorry. So let's look at this problem now. All right, so this one, since it's or, you have to solve separately. All right, so you have to solve separately. So look at this. So for this problem, if you actually distribute this, it'd be really big. So let's not do that. Let's not do that. So let's divide both sides by 15. So -3 is less than or equal to 7x plus 18. Right? And then or, actually, let's do that later. Okay, then we have our -21 is less than or equal to 7x. So x is greater than or equal to -3. All right, then we have, let's do this. Okay, let's multiply everything by 9. We have -90 is greater than or equal to 10x. Right, so x is less than or equal to -9. Right? So let's look at this. So the interval notation for this, right, is actually going to be negative infinity, -9, union, -3. That's actually included, right? Those are both included to infinity. All right, so that's the interval notation. So the third problem, this one is actually combined. So we're running out of time, so let me just walk you through this one. So this one is multiply everything by 5. It's going to be 60 is greater than for x minus 8 is greater than negative, what is this? -80. Okay, then you have to add 8 on both sides. We have 68 is greater than 4x, and then which is greater than -72, and then divide everything by 4. You're going to get 17 is greater than 4x is, which is greater than -18. Okay, so that's how you do it. All right, it's going to be -18 to 17. Right? Very good. So, are there any questions on this? Any questions? If there are no questions, then I'll go on to the first one you already graphed already. So let's go back to the second one. So that was -9 to, okay, I think I got it. So let's draw this. So we have our -9 here and our -3 here. And it was greater than or equal to -3 and less than or equal to -9. All right, so it's like that. And then our problem 3, what was that? It was -18 to 7. Very good. So we have -18, 0 to 17. 17. All right, so, and then they're both not included, so it's going to look like this, right? It's in between the interval, in between 2 points. All right, so thank you for listening, everybody. That's our last problem. So thank you for listening. All right, and I'll see you next time. First of all, any questions? Any questions right now? Like, I was a bit rushed there at the end. Are there any questions?